I suggest that we go ahead. Of course, we expect more people to attend and hope that they will still join us afterwards. But regarding the timing, I think, Christoph, that we can start.
All right. So does everybody hear me now? Okay.
Yes.
Okay. So good afternoon, ladies and gentlemen, and welcome to the debate organized by EUPAVE on the topic of climate resilience and long-term transport investment. My name is Christoph Nicodem, and I'm the Director General of the European Union Road Federation, an association representing the sector of the European road infrastructure. And I'm quite pleased to be the moderator of this event this afternoon. When we talk about climate resilience, obviously we all think about recent series of natural disasters like floods, droughts, eruption, and in general, a series of different effects and consequences of the global warming. And all these elements obviously affect our transport infrastructure. And because these phenomena become more and more common and come more regularly, and if we consider the importance of transport for our economy, it is essential to have a new approach regarding transport infrastructure and the necessary investments to make it more resilient, capable to withstand and mitigate these effects. So this obviously requires a long-term vision. And this is why I really consider the event of this afternoon to be of a particular interest to address this topic. And I would like to thank EUPAVE for organizing it. And I would like now to give a very special thanks to our host this afternoon, Ms. Isabel García Muñoz, Spanish MEP of the Socialist and Democrat Group in the European Parliament and member of the Committee on Transport and Tourism. And as our host, I would like now to give you the floor, Mrs. García Muñoz, for the introduction and the welcome to the program of this afternoon. The floor is yours. Thank you.
Thank you, Christoph. Good afternoon, everyone. I would like to thank you for being here with us today. Allow me to warmly thank the European Concrete Paving Association, Mr. Luc Renz, Managing Director, and Mr. Stefan Nicode, President of the EUPAVE, for this important event and for giving me the privilege of welcoming you all. I would also like to thank Mr. Klaus Kondrup from DG Klima for being here to discuss with us one of the main challenges the EU is facing, climate change consequences from a technical, climate resilient and sustainable approach, presenting the climate proofing infrastructure guidance. It will also be a pleasure to have with us Mr. Jim Mack from CEMEX USA, who will present for us the topic of pavement resilience, EU's experiences and recommendations, and of course, Mr. Christoph Nicodem from European Roads Federation, who will moderate the debate. I would like to introduce myself briefly. I am Isabel García Muñoz. I am a full member of the TRAN committee. I have been involved in several files related to networks and financing, namely the negotiation on the current Connection Euro facility, the revision of the Trans-European Transport Network, and the most recent Parliament report on road safety. The topic of today's debate is a very interesting one because it relates very hot topics of the EU transport policies agenda: resilience, infrastructure, and financing. However, we have to understand and analyze these three concepts within the current political and socioeconomic context. As you are all aware of, climate change is at the core of the European Union agenda, and in consequence, it has an influence in the three subjects we will reflect on during today's session. Climate change is a serious concern for Europeans. The impact of global warming is transforming our environment, our societies, and our economies. Extreme heat waves and climate-related extremes, such as forest fires or flash floods, are becoming more frequent in Europe, but also around the world. We are already noticing the severe consequences on the productivity of Europe's economy. Availability to produce food, public health, biodiversity, political stability, and without any doubts in infrastructure. Believe me when I say that I know this firsthand. Coming from Spain, I can guarantee we have experienced more extreme weather these past years. My region, Aragon, suffered from the severe snowstorm Filomena last year and had a terrible impact in agriculture and infrastructure, among others. Before this scenario, the European Union has responded and committed to be a leader in the global fight against climate change and in favor of climate neutrality by 2050. The European Green Deal has become the EU roadmap to achieve the latter and has set the strategy to accelerate the transition towards a modern, competitive, and climate neutral economy. And as I have said many times, no one can be left behind. There is no doubt that all sectors have to do their part in the transformation, including the industry and the transport sector. However, there should be support for these sectors and workers, which are more vulnerable to the transition. In the case of transport, the Commission presented more than a year ago their Sustainable and Smart Mobility Strategy, which defines the path to achieve 90% reduction in transport-related greenhouse emissions by 2050 and make the sector more competitive, safer, and more affordable for all. The first flagship of this strategy recognizes the importance of fostering and updating infrastructure in line with the new digital, green, and security needs. It also gives a central place to resilience and recognizes that ensuring our transport system is truly resilient against future crises must be a key objective of the Union's transport policy. As I mentioned before, I was part of the negotiation team for the Connecting Europe facility for 21-27, a financing program which will be key to achieve the targets of the European Green Deal and, in consequence, of the mobility strategy. We actually ensure 60% of the new CEF's budget will be allocated to projects in line with the Union's climate objectives and transport models. We succeeded in recognizing resilience of infrastructure as a financing priority. Nowadays, CEF supports actions improving transport infrastructure resilience, in particular to climate change and natural disasters and cybersecurity threats. Something to introduce in the debate is that the materials we construct infrastructures with can also have an impact in sustainability, making vehicles pollute less and therefore contributing to the green transition. In addition, resilience of infrastructure can, among others, improve not only sustainability, but also performance and safety of the transport network. It can avoid possible damages, prevent accidents, or have the adaptability to make it more user-friendly to people with reduced mobility or with disabilities. I cannot forget to mention the recent Commission's proposal for the revision of the Trans-European Transport Network, where resilience has a very important place. The revision contains provisions on resilience and quality of infrastructures for each mode of transport. Moreover, it incorporates a new specific article on resilience of infrastructures, something which I consider very good news. Since, as I previously mentioned, climate change is accelerating and infrastructures need to be adapted and ready to address other challenges related to cybersecurity or traffic disruptions, which will be crucial if we face another crisis in the logistic chain, such as the one in the Suez Canal. Finally, yet importantly, I would like to comment that infrastructure and resilience will play a vital role in the global gateway strategy announced by the President of the Commission, Ursula von der Leyen, because of its strategic importance and influence in the European Union socioeconomic and security spheres. This is why today's debate is so pertinent and up-to-date. This session should allow us to reflect on ways of making EU transport more resilient, how to address the green and digital transformation of the sector, and how to find the technical solutions, both viable and beneficial for the safety of people and environment, which are capable of updating to the new challenges. Of course, no objective or need that we mentioned today could be achieved without targeted investment. This is why I would like to invite you to also reflect on the possible smart synergies between national funding and EU funding programs, such as CEF, ERDF, Cohesion Fund, Recovery and Resilience Facility, and also reflect on how to effectively attract private investment, give investors legal certainty to support and advance in this common goal of ours, making infrastructure more resilient and sustainable, in other words, more fit for the future. I would like to thank you, all of you, for your attention. And now I would like to give the floor to Mr. Stefan Nicot, President of EUPAVE, whom I would like to thank again for his confidence. I wish you have a fruitful debate. I will have to leave you now because I have another meeting starting now, but my assistant will follow the event and take notes. And you, of course, can contact me if you want to continue the discussion. Thank you very much.
Thank you very much, Ms. García Muñoz, for this very detailed and pertinent introduction. And without losing time, I will now give the floor to Stefan Nicot, President of EUPAVE.
Thank you, Christophe. Hello, everybody. On behalf of EUPAVE, I would like to welcome you all in this debate on climate resilience and long-term transport investment. First of all, I would like to thank our honorable member of the Parliament, Mrs. Isabel García, for her nice words and for hosting our annual event in such special circumstances. Indeed, since the beginning of its existence, EUPAVE has organized an annual event hosted by prominent EU decision makers, promoting debates and exchanges on key EU issues. I would also like to express gratitude to all the speakers of our today's debate, and particularly to the representative of the European Commission, Mr. Klaus Kondrup, whose contribution, I'm sure, will be highly appreciated in a moment where climate proofing infrastructure and so-called climate mainstreaming is affecting the whole European industry. EUPAVE, the European Concrete Paving Association, is a non-profit European association which promotes the benefits of cement and concrete for transport infrastructure and related areas. We are committed to promote and defend the specific contribution of concrete to higher road safety, public spending efficiency and sustainability in roads, tunnels, urban areas, railway, tram, bus lanes, and airfields. EUPAVE plays a promotional and technical role for the benefit of its members, be it national cement associations, road designers, road contractors, material suppliers, equipment manufacturers, etc., by means of exchange of experience, know-how, best practice, and also technical brochures and promotional material. EUPAVE is very active also in liaising with public authorities like the European Parliament, but also with the Commission to raise awareness on the high benefits of concrete for transport infrastructure and vastly untapped benefits of concrete pavement solutions. In this regard, EUPAVE has produced numerous position papers and fact sheets on road-related European issues, such as circular economy, high albedo and less fuel consumption, zero maintenance road, green public procurement rules, and desirable competition between pavement industries. And most recently, EUPAVE published a new fact sheet on climate resilience that we will distribute after this event. We believe that this publication can help plan, design, and build the sustainable roads of the future. Ladies and gentlemen, the adaptation to climate change calls on each of us to contribute to this immense mission from our area of expertise. We in EUPAVE, we are ready and would like to fully participate with this event in the debate for a better future for all and more resilient transport infrastructure and roads. I therefore hope for a lively and fruitful debate on the choice required for more investment on climate resilient transport infrastructure. Thank you and enjoy the debate.
Thank you very much, Stefan, for these introduction words. Now we will go to the presentation session. We are slightly a little bit late on our program, so I would like to ask all the speakers to try to stick to the planned duration for the presentation. Our first speaker will be Mr. Luc Rens, Managing Director of EUPAVE, who will deliver a presentation on climate resilience and long-term vision of road. Please note that there will be a possibility to ask questions to the speakers after the presentation. There will also be a possibility to ask questions during the debate that will take place after the three presentations. But we are going to try to stick to our timing. So Luc, the floor is yours.
Thank you, Christophe. So my presentation is a very general one. A short introduction to the more detailed presentation of my dear colleague Jim Mack from Siemens, which will come afterwards. And my presentation is based upon a fact sheet that we drafted within our working group on environmental strategy within EUPAVE. It's a brief document that collects a number of statements, facts, and figures on the different aspects of resilience to the direct and the indirect consequences of climate change. Well, we drafted it last year in 2021. It could not have been more topical at that moment, unfortunately, with the floodings in Western Europe and the wildfires in different places in the world. In our document, we focus on concrete roads, but to be clear, EUPAVE scope covers, let's say, all kinds of transport modes and infrastructure, such as pedestrian areas, bicycle lanes, bus lanes, heavy rail and light rail, and even air transport. In our fact sheet, we start with a few definitions. The first one you see, one from the Intergovernmental Panel on Climate Change, a long definition. I let you read it. You see it ends with maintaining the capacity for adaptation, learning, and transformation. Well, it's not easy for a hard infrastructure to learn and transform. So let's say that in our context, we consider it more as resilience as the capacity to absorb stresses, to remain functional in the face of external stresses imposed upon it by climate change. So we do focus now on the consequences of climate change, although that other hazardous events could lead to the same criteria, to the same conclusions. Let's take a look at two main consequences of our changing climate that affect our road infrastructure. So the increase in temperature and also the increase in precipitation. Or maybe it's more the increased occurrence of extreme temperatures. More heat waves will lead to a higher risk of rotting of bituminous surfaces due to the viscoplastic behavior of that material. More rotting is also a higher risk for aquaplaning, so it's a dangerous situation. Also, pre-thaw cycles will be intensified, mainly in the north and center of Europe, and that can accelerate the deterioration of different types of pavement. It will require adapted designs. And yes, another consequence of dry and heat periods or the wildfires. And very recently, we could hear in the news that the fire season in California is starting earlier and ending later each year. And obviously, climate change is considered as a key driver of that trend. The increased precipitation and the flooding disasters are becoming part of our lives. The main risk for the transport infrastructure or erosion of embankments and foundations or loss of road structure integrity, pavement integrity, and Mr. Mack will go more into detail of this in his presentation. And yes, we could be a bit more optimistic. However, if we look at the figures published by the European Environmental Agency and by the Joint Research Center of the European Commission in their technical reports, then it is not all that optimistic. 2011-2020 was the warmest decade ever recorded, with global average air temperatures reaching 1.1 degrees above the pre-industrial levels. And the rate of increase now for human-induced global warming is about 0.2 degrees Celsius per decade. And an increase in frequency and duration of extreme temperatures is also projected, mainly in the south of Europe. Projected increase in weather-driven fire danger in southern Europe is about 30 to 40% by the end of this century, compared with the end of past century. And the same is for heavy rain in winter and summer for Europe. So about the end of this century compared to 71-2000, you see increases from 25 to 35%. So that is enormous. And another consequence of natural disasters is the necessary removal of debris. Unfortunately, trucks carrying debris are unavoidable in the event of severe damage after floods or wildfire events. And this transport mostly happens, but it consists of heavy goods vehicles driving on roads that basically have not been designed for that. It means an increase in unevenness, so less smooth surfaces, and also a faster degradation for asphalt roads was observed by researchers in comparison with concrete. Yes, we know that rigid concrete pavements are less impacted by overloading and provide a higher resilience to flood and wildfire damage. Well, here we see an infographic that we also drafted within EUPAVE. In the upper right corner, you see the higher resilience to climate change, but I also want to draw your attention to the upper left corner, less global warming, and that is about mitigation. There are two aspects. The high albedo, which is related to the light color surface, leading to a larger part of the incident light that is reflected to the upper atmosphere, slowing down global warming. A second effect is reduction of fuel consumption for heavy goods vehicles driving on concrete compared to asphalt. The following slides will give the figures. Here you see that when you change a black into a lighter color surface, asphalt to concrete, you save an equivalent of 22.5 kilograms of CO2 per square meter. And that is equivalent to about 30 to 60% of compensation of the CO2 emitted during cement production. And this is the figure for the reduced fuel consumption, up to 2.35% for heavy goods vehicles on concrete compared to asphalt. Also, that is a significant reduction. And another contribution to the risk of flooding is the use of pervious pavements. Both precast elements and in situ cast pervious concrete can be used for this purpose. You see a few nice examples on this slide. So the societal benefits of a resilient, robust and road network are numerous. First of all, it saves lives, thanks to the positive impact on road safety, and also while guaranteeing a free traffic flow for emergency services, ambulances, firefighters. Secondly, it allows us to save money thanks to the lower repair costs. And in addition, there is a lower impact on economy thanks to the increased availability of the transportation network. And finally, this is also better for the environment, since there are less impacts from emissions and use of resources for rehabilitation or reconstruction of the infrastructure. Regarding the way to go ahead in building and adapting our infrastructure, I'd like to refer to a publication from the Organization for Cooperation and Economic Development, the OECD. It's called Climate Resilient Infrastructure Policy Perspectives. And I give you here a few statements. So infrastructure will be affected by the climate change, but it will also play an essential role in building resilience to the impacts. New infrastructure assets should be prioritized, planned, designed, and operated to account for the climate changes that may occur over their lifetimes. And existing infrastructure may need to be retrofitted or managed differently given climate change. Well, concrete roads are a part of that solution, either as a newly constructed pavement or as an overlay on existing concrete pavement. It is important to conclude that decision makers have access to a high quality information, to consistent data, so that they are able to manage the climate related risks. And a final statement is that public policies should promote resilience and include public procurement processes that consider climate resilience when comparing competing bids, simply by accounting for the cost over the asset lifetime under those scenarios. Ladies, gentlemen, I thank you for your attention.
Thank you very much, Luc, for this quite interesting presentation. Do we have any question from the audience? You have the possibility of raising hands or using the chat box. Well, it seems that either it is the end of the day or your presentation have been absolutely crystal clear, Luc. So if I don't see any question coming from the audience, I would like to ask you a question. You have shown a slide on the use of water permeable pavements, I think, of pervious pavement as the mitigation effect, can have a mitigation effect to climate change. And can you maybe explain a bit more what to which extent this pervious pavements are able to prevent floodings or to cope with those sort of extreme events or disasters?
Yes, I can. Well, the pervious pavements, water permeable pavements are a very good application. And in case of a very generalized use of it, for instance, on streets, sidewalks, also on private properties, this will definitely reduce the amount of stormwater that needs to be evacuated. So it will have a positive impact on the prevention of flooding. And let's not forget, it also plays an important role in the fight against drought and lack of groundwater. So it's also very important for that.
Right.
Now, on the other hand, I think in areas with a high risk for flooding, it is probably wiser to choose for a more robust design. Let's say I would rather go then for a base layer, for instance, in a lean concrete, which is maybe not permeable, but which will better resist the washout effect of a strong current compared to a water permeable unbound aggregate base, which would be less resistant. So I think, yeah, both aspects have to be considered. So the permeability, allowing the water to infiltrate in the soil, that is important, but also the robustness of the solution itself.
Okay, so then we can really see that the topic is more complex than we could suppose at the beginning, and you have to take different criteria into consideration. Thank you for answering this question. Is there any question from the audience?
Yes. Question in the chat, Christoph.
Is there a question in the chat?
Yeah.
How would you quantify whether a pavement is more resilient? I'm sorry, Stefan, I didn't see the question in the chat, but thank you for mentioning that.
Yes, the quantification is obviously a difficult aspect, but with my last statement, I already gave some possible solution. When let's say, in some cases, you do have to define the resilience or the robustness, or you have to look for solutions that will withstand the possible effects for future worst case scenarios. And that means that probably we will come to overall solutions which may be more expensive. Well, in that case, those costs should already be accounted for over the lifetime of the asset, taking into account. It is maybe like from other criteria, it may be easier in a PPP, public-private partnership. And in that case, it's important, I think, to clarify the allocation of the responsibilities regarding climate-related risk planning, management, and response. But
okay, thank you.
Hope this gives somehow an answer to, but of course, it's not a pure quantification of the resilience.
Okay. Thank you for this explanation. I know, yeah, the person who said, who asked the question said, I know it's a difficult question. You tried to give some elements, which is quite nice. I think that we would now have to go for the second presentation. Thank you, Luc, for your first presentation. And our next speaker is Mr. James Mack, PE Director, Infrastructure Market Development of Cemex USA. And he will present us an extra-European perspective on pavement resilience with US experiences and recommendations. So, Mr. Mack, the floor is yours.
Thank you. Thank you, Christoph. I appreciate it. I'm assuming everybody can hear me. Could somebody please confirm that?
Yes, we can hear you.
Perfect. So I appreciate the opportunity to be here. Unlike the rest of you, I am just starting my day here in the US, so I appreciate the opportunity to come and talk to you a little bit about pavement experiences and resilience. And along the way, I hope I answer part of that question that was just given. So start off with, make sure I want to kind of put a framework around this. And so what we have on here on the left are the number of climate-related disasters that have happened since 1970. And what we have on the right is the economic impact. And from this chart, we can notice a couple things. Is one, we are starting to see a lot more climate-related disasters. They are happening, you know, it's proof that they're out there happening. But we also can look at this and say that flooding is the most common and often the most expensive of all these climate-related hazards. And why this chart goes up to 2019, I read 2 weeks ago that they've come out with the number for 2020, and it was at $200 billion worth of economic impact due to flooding and extreme weather across the world. That makes it the second or third worst year ever. And so we see that it's a continuing trend. And I'm going to focus on flooding because that is, again, it's the big one. But when we look at flooding, we need to distinguish between two types of impacts. The first one is what we call washout, and that's what's on the left, and it's a very dramatic, it's where rapid flow of water, high current washed out and scours away part of the pavement structure. Now, this is what everybody focuses on, and while it's dramatic and everybody likes, everybody notices it, it's relatively isolated. It doesn't happen very often. What we see more of is the impact on the right, which is called inundation. It's not very dramatic, but it's much more widespread. This will cover hundreds or thousands of kilometers of roadway, while the one on the left might be 1 or 2 spots. The one on the right will cover everywhere. So there's no rapid flow of water in here. It's just generally the rise of water and just covering everything over a very large area. We also have to distinguish between the types of flooding or where they come from. And there's basically 3 types. There's river flooding, there's hurricanes, typhoons, and storms that flood. And then there's something we call sea level rise or tidal flooding, or what we sometimes call sunny sky flooding here in the US. Of these, I actually think the river flooding is the most dangerous and probably the most destructive source. Here in the US, it happens mainly along the Missouri River, which is a river right through here, along the Mississippi River, and it can cover very large areas. And the reason why I think it's one of the most destructive sources is because you get both inundation. For example, in Nebraska, they had 1,500 miles of roadway closed just because the roadways were underwater. But you also get very heavy washouts in these areas. These are rivers, so there's rapid flowing waters. And when these rivers get out of their banks, we see that they actually destroy the roadway, so we get washout. Now, in Nebraska, why this was 1,500 miles, this happened the next year in Iowa, and this was about 15 miles. So there is, again, an order of magnitude between the difference of it. This is what everybody focused on, but this is what covered more area. And this is what happened in this past year in Germany and Belgium. And again, from my perspective, from what I've seen, this is one of the most destructive river floodings I've ever heard about or read about. Typically, we see, like I say, the washouts over a small area, but what I saw happening to you all in Central Europe, it was a much more egregious case of what's going on. The next type of flooding is what we call, or we get with, usually it's hurricanes, or it can be any type of heavy storms. These are typically inundation type events. There can be some washout, but again, it's just usually the large amount of area being covered. Here in North Carolina, they had something like 2,200 miles of roadway closed at this time. Florida gets hit with 2 or 3 hurricanes a year, and we see very common for roadways and pavements to be flooded. This is my home area. I live in Houston, Texas, and we've had 4 hurricane events that have flooded Houston, Texas since I lived here. I've lived here for about 15 years. The biggest was Hurricane Harvey, and it covered about 65,000 square miles. No washouts, but a lot of inundation. It was all just inundation flooding. And the final one is sea level rise, and this is the most benign of the flood events. It's just the general rise of water. It can occur on a daily basis. It doesn't really impact. There's no flow associated with this. It's just the rise of water, and we call it nuisance flooding or sunny sky flooding. While it kind of is inconvenient, it also does destroy our pavement systems over time. So we need to be able to address it. Now, to start addressing resilience with paving and those events that happen, we need to kind of understand how to define resilience and how to and have a framework around it. So this is a resiliency framework. It applies equally well if you're a building and you're dealing with fire, earthquakes, a country dealing with a pandemic. This is the general framework that it goes on. And so the way resilience is defined is I have a system here, and it's performing along at some given level of performance, and then the event hits, such as flooding. And the resiliency is defined by 2 parameters. One is how big a drop in performance do I get, and how long does it take to recover? And in this system, a green is more resilient than the orange because there's a lower drop, there's a faster recovery time, and it recovers to a higher level of service. Now in this system also, the blue is what we call a hardened system, because what we're doing at this time is we're building back better so that when the next event hits, we're going to have a smaller drop in performance. We may still get a drop in performance, but we're still going to be at a level that we can deal with. Now, the issue with payments and resiliency is that we have to define what performance is. And there's two types of performance when it comes to payments. There's functional performance, and that's basically, is the pavement open and can vehicles and the general public use it? It's relatively quick and easy to see. It's basically, can I drive on the roadway? And if I can drive on the roadway, if I don't have any washouts and there's no water on the roadway, I'm back to my functional performance or my functional resilience. The one we have to worry more about is what's called the structural performance. And this is the hidden one. This is the one nobody sees about. And once a pavement is flooded, what we can see is it can take years for that pavement to recover. And the entire time that pavement is being used, there's damage being done to that pavement. And so we actually don't really see the issues until all of a sudden our pavement systems are being rehabilitated 5 or 10 years earlier than we were expecting them to be. We also have to recognize that when we have flood events, that damage comes from two different sources and at times. There's that primary and direct impacts. That is my roadway flooded, or am I having a washout and can I use it? But the second one is these secondary or indirect impacts. And pavements are a unique component, or unique system, because not only do they have to withstand the event or the climate change event, but they also play an important role in the recovery. We're going to use our roadways for rescue and emergent responses during the disaster. During the recovery, much like Luke talked about, we're going to have to do cleanup and rebuilding after the disasters, and we're going to load these pavements. And we're not going to wait for the pavement to recover. When people's lives are in danger, we're going to load these pavements. We're going to get people safe. We're going to worry about that. But as these after these disasters occur, we have a huge amount of material to remove away. This is, again, not too far from my house, from after Hurricane Harvey in Houston, Texas. After Hurricane Harvey, we had to remove about 200 million cubic meters of debris. And 65% of that, I mean, this was a very common, so all this was removed in about 65% of this was removed in about the first month. That's about 8 to 10 years worth of loading on the streets that weren't designed for it. They just weren't built for that, So there's a huge amount of that of recovery, and then there's the rebuilding after. After all this is removed, there's all the trucks moving back in with rebuilding of these roadways. So we need to be able to withstand both. So when we look at pavement resilience, not only do we have to deal with the primary impacts, but we have to make sure our secondary impacts and kind of design around those too. So again, in this system, the green is more resilient than the orange because it's less drop, faster recovery, higher level of surface, but also less secondary damage. So we need to be able to design our pavements to withstand the loading during the weakened state. So how do you do that? Luke kind of addressed this, and there's 3 ways to do it. One is we want to build in what's called robustness. And essentially with that, we're making a stronger system to minimize that drop in performance. The other thing we want to do is we want to build in redundancy so that there's extra elements that take over in case there's some type of a failure. And the easiest way to explain a redundancy is to think about a city that's on a coast. If there's 5 roadways leading into that city and one of those roadways floods, there's still a large amount of redundancy. There's 4 other roadways that people can use to get in and out of that city. But if there's only one road leading into that city and it floods, there's no redundancy and there's a great crisis going on in that city. And so we have to be able to build in those redundancies in our system. And the final thing is we want to mitigate the secondary damage. And so to do all these things, what you need to do is understand the vulnerability, and you need to actually design around these for each climate hazard. So when we go to flooding, we go back and we look at the washout. And when we look at washout, pavement type doesn't have a whole bunch of impact. Whether it's concrete or asphalt, both pavements are very susceptible or are susceptible to washout. It's more about the structure and the things you build around it. However, for inundation, pavement type does have a large impact, and the pavement type plays an important role in there. And this is the reason why, and I'm sorry, but I'm gonna have to go a little bit technical on you for a second. But when we design pavements for what's called optimum moisture content and optimum density. So what we do for the base material, the sub-base material, the subgrade materials, the materials that's just under the top surface, we compact them at the right density so they're at their strongest level. And the reason we do that is for an asphalt pavement, which is called a flexible pavement, as we load it, it delivers this large spike. But we design these pavements with a strong base, a strong sub-base, and the right thicknesses to minimize the impact of this pressure. So it's no big deal. Concrete pavements are a little bit different. They deliver the load different. The concrete carries the load, so it spreads the load out over a large area. We still want that optimum moisture density and that optimum strength, because it helps put the system perform. But the main load carrying capacity system in this pavement type is the concrete itself. Both systems work fine as long as they stay dry. The problem is when we have inundation flooding, that subgrade becomes what we call supersaturated, and basically the water gets into the base and it pushes all those particles apart. So what happens is this base, sub-base, and subgrade layer, their strength is lowered, and we lose load carrying capacity. Once the water goes away, it takes about a year for these materials to regain their strength, but the loading during that time is taking away life from the system. So it's a weakened system, and it just starts to accelerate the damage to it. The concrete pavement, the materials underneath, the sub-base and the subgrade still get supersaturated. They lose some of their strength, but the concrete doesn't. It's still carrying the load. So even though this is less strength, we never stress it to the point where we actually damage those systems. And so we don't get the damage to the roadway of the asphalt and the concrete pavement. And we can see this. This is some history. This is from a pavement that was flooded in Florida. This roadway was flooded after a hurricane for about 2 weeks, 14 days, 10 days, something like that. And the Florida DOT just happened to test the strength of it before this flooding. And this was the pre-level strength. And this was the strength of the pavement system after the flood for the 6 to 8 months after it. So we had this reduction of strength. Now, this doesn't look like it much, but it's about a 40 to 60% load reduction in carry capacity. And it was about 3 years to 4 years off the life of this pavement. It is intended to be a 12-year pavement, and they lost a third of their life of their pavement. You can contrast this with pavements in concrete and in Houston. Houston is a very concrete-centric city. We have very stiff pavements. We have cement-treated bases on them. And these are some of the flooding events we've seen. And, they're flooded for 3 or 4 days. And in Houston, we literally put traffic on it. As soon as the water is about a half an inch thick, we open our roadways up and put traffic on them. We've gone out and tested these roadways. We've had no damage in it. In fact, we can tell because these were designed for what they call 43 million easels. It's carried 92 million easels. Easels is a way to describe trucks, and that's what pavement engineers use. Here's another one. It was designed for 7 million easels or 7 million trucks, and it's carried 22 million easels, 3 times more traffic. And so what we see is stiffer designs work better. You want stiff designs. They have a lower drop in performance. You can open them quicker, they have a shorter recovery time, and they have less secondary impacts. So the question is, how do you get there? Well, one of the ways, and one of the best ways is with new pavements, and this is what Australia's done, is they no longer design for optimum moisture content. They design for all their pavements to be flooded. They look at the amount of rain that's going to be in an area. They say, based on the amount of rain, we're going to use what they call a soaked subgrade value. They actually reduce the strength of their subgrade in their design, so they just build more robust systems from the very beginning. Another thing you can do is stabilize the base. Luke talked a little bit about this, is where they come in and they take these unstabilized base materials and they mix in cement, and they basically make it a much more resilient, robust structure, and again, it changes the profile. My favorite is actually use concrete overlays. Because when we use concrete overlays, we get two things that are happening. One is we raise the road elevation by a little bit. And so we're looking maybe somewhere between 150 to maybe 300 millimeters of elevation increase. But more importantly, we change how the pressure is applied to the underlying layers. We go from this spike where the underlying layers can't handle it to this much lower pressure diagram, and so it actually increases the structural capacity of the roadway. So we know how to make our roadways more resilient. Flooding is a big risk, and we need to account for both the primary and the secondary impacts. But there are ways to stiffen your pavements. Concrete overlays, full depth reclamation, just designing your pavements from the very beginning with a lower subgrade strength will make our systems more resilient. With that, I'd like to thank you again very much. I appreciate it, and I'm open for any questions.
Thank you very much, Jim, for this quite extensive presentation and very, very interesting element. Are there any questions from the audience? Stefan, I see that you raised your hand.
Yes, thank you, Jim, for this great presentation. Very interesting. I have several questions, but the first one is, what does the federal government do right now about road network resilience? Is it a big topic? Is it part of a Biden plan? Yeah, what's going on this topic in the US?
Yes, that's a great question. And in fact, yeah, it's becoming a much bigger topic. It started become a topic probably about a year and a half ago is kind of when it is. And now the states are all starting to talk about it. And when they first started talking about this, everybody was talking about, well, we're going to build bridges, we're going to raise the roadway over all of our roadways. And everybody quickly determined that's not a very cost-effective way. You can't raise 1,500 miles of roadway in Nebraska. It's just not feasible. So they're starting to look at ways to harden their system and how to do this. And so people are starting to look at all these other solutions to do this. It is a big part of the Biden Build Back program. And so another thing the states are doing is they're also kind of focusing on where they're having problems. One of the things we're doing is mapping out much better where our pavements are going to be flooded and how do we upgrade those. And one of the things that Luke talked about earlier was competition. And so in several states they're looking at, hey, we want more competition between the concrete and the asphalt industry. We need to build more resilient roadways. Concrete are more resilient. Let's put concrete in those flood prone areas. And that's kind of where they're looking at putting a lot of concrete pavements now. Okay,
thank you. And then I had a second question, you partly answered it. I've seen in your footnotes that some of the models for resilience came maybe from federal highway.
Yes.
So is it a public or a governmental modelization of resilience? And did they reach the conclusion themselves that they need stiff pavement to solve the problem?
Here in the U.S., we have the federal government, but we also have each state, and each state does its own thing. And so this is kind of a conglomeration of several states, several countries, research looking at it. And the general feeling is, yes, different pavements are what they need to be going to. And so like a lot of this research is from Louisiana. Another good part of it is from Australia. A lot of it's from Missouri and Iowa. And they're the ones who have had the problems that have done most of the research. So now a lot of it's getting out. I will say the U.S. government is just starting a very large research project where they're looking at the functional or the structural resilience of pavements, and they're going to fund about $1 million research to look at that, and that's going to hopefully start in March or April.
Okay, thank you. I have another question, but maybe Christophe, if you see somebody else.
No, I don't see any other question. But if you have another question, Stefan, can you do it very quickly because we're already some 15 minutes late.
Just one question. You said you like very much the concrete overlay solution. Do you have an idea of the type of cost per square meter we are talking about? Per kilometer, I don't know.
Yeah. Yeah, no, that's a good question. The cost it kind of depends across the U.S. where we're at, but we're finding for the most part the concrete overlays are cost competitive with any asphalt solution right at the beginning. They are some places it's 5% more expensive, other places it's 5% lower cost. So they are not here in the U.S. are not way out of cost differential versus the asphalt payments at this point. They are kind of on par, and it depends on the particular solution looking at, but that's where we're at with those.
Thank you.
Yep.
Thank you very much, Jim, for this presentation and all your answers. And we go now for our third and last speaker, who will present the institutional point of view. It will be Mr. Klaus Kondrup, senior expert of DG Klima on the European Commission, and he will present the European Commission's technical guidance on the climate proofing infrastructure in 2021-2027. So, Mr. Kondrup, the floor is yours.
Good afternoon. Can you hear me?
Yes, we can.
Very good. And I hope you can see the slide.
We do see the slide, yes.
Okay. Thank you very much for the invitation. It's really great to be here and some very interesting presentations before me. So thank you very much. I will present the technical guidance on the climate proofing of infrastructure in the period 2021 to 2027. And that is the 7-year EU long-term budget period that we are in for the moment. So that's why we have the 7 years. And the guidance that I'm going to present responds to requirements on climate proofing of infrastructure, which you find in legislation for various EU funds in this budget period 21 to 27. It's also linked to the principle that all EU expenditures should be consistent with the Paris Agreement, and it's linked also to the European climate law. Let me see if it works. It is. So the guidance was adopted by the European Commission in July last year, and it was then published in the EU official journal. And since this is the EU, it was published in 23 languages in September. And it's intended for EU-funded investments in infrastructure, but of course you can also use it for infrastructure that's not funded by the EU. So the new guidance is for the period 21 to 27, but it builds on lessons learned from major projects in the previous 7-year budget period from 2014 to 2020. And major projects are large infrastructure projects from 50 to 75 million euro and up. So many of the EU member states are already familiar with the climate proofing of infrastructure, like in transport. So what we have now in the period 21 to 27 is several things. The overall climate target for the EU long-term budget has increased from 20% in the last 7 years to now 30%, and that means more climate action. And climate proofing will cover more EU funds than ever before, and a wider range of types and sizes of infrastructure projects. So it will no longer be restricted to the so-called major projects. As regards the mitigation of climate change, the guidance includes an updated and more ambitious approach to the quantification and monetization of greenhouse gas emissions. As regards the adaptation to climate change, the climate vulnerability and risk assessment benefits from various developments. For instance, the large investments in the European Space Programme and the EU-funded Copernicus Climate Change Service, which now makes reliable and quality-assured climate data available for free to support the climate resilience work. The move away from major projects to a wider range of EU funds calls for guidance on documentation and verification of the climate proofing process, and that is now covered by the guidance as a new thing. The new guidance covers in detail the coordination and thereby potential time and cost savings between climate proofing and environmental assessments, notably the Environmental Impact Assessment, EIA, and the Strategic Environmental Assessment, ACA. And the guidance also includes in Annex F recommendations reflecting lessons learned from major projects on how individual member states can support the climate proofing of infrastructure in their territory. The climate proofing process is divided in two pillars, which reflect the important difference between climate change mitigation and adaptation and the different policy objectives. We treated differently the two pillars. The split in two phases brings efficiency gains in response to a legal requirement laid down in the InvestEU regulation. So on the slide, you have climate neutrality to the left and climate resilience to the right, and you have phase one with the green background and phase two with the maroon background. So a range of EU funds may support investments in infrastructure. And you find in the fund-specific legislation the definition of what is eligible infrastructure under that particular fund. And the climate proofing guidance is drafted with a wide range of infrastructure in mind. So it's not focusing as such on road transport infrastructure or road pavements. So here on this slide, we look at the mitigation of climate proof, the mitigation pillar of climate proofing. And it illustrates the screening phase with green background to the left and the detailed analysis to the right. The guidance includes a screening list of various types of infrastructure, including transport, which in many cases will simplify the work. In other cases, like inland waterways, it may be necessary to estimate the greenhouse gas emissions and compare with threshold values in the guidance. The detailed analysis in phase two includes quantification and monetization of greenhouse gas emissions, which the guidance refers to the carbon footprint methodologies of the European Investment Bank, the updated shadow cost of carbon published in the EIB Climate Bank Roadmap. If we move on to the second pillar, climate resilience, the approach aims at identifying and assessing the climate risks, which then can be addressed through relevant adaptation measures. These measures will have to be identified, appraised, planned for, and implemented. There is considerable uncertainty involved in this exercise, among others from the future level of greenhouse gas emissions and global warming, which, notably for long-lasting infrastructure, they warrant regular monitoring and follow-up of critical design assumptions. And we cannot build and then just leave our infrastructure without keeping an eye on it. But on the other hand, the guidance provides for flexibility and stepwise adaptation, which can be more cost efficient and attractive. In addition, infrastructure investments should give due regard to adaptation strategies and plans at various levels of governance, member states, regional, local. Finally, the climate proofing process and related decisions should be documented, which you find in the middle of the slide at the bottom. The documentation will usually be an important part of the investment decision. And the climate proofing documentation is intended as a relatively short, summarizing document, typically in the range of 10 to 20 pages. However, it should then be possible as part of the preparation of the investment decision to query and obtain further insights into the underlying documentation from the project developer. Coming to the second last slide, the guidance emphasizes the integration of climate proofing into the project cycle management, which is common for infrastructure projects. Moreover, the guidance elaborates on the close links to environmental assessments, the EIA and the SCA, and details are included in Annex D and E of the guidance. So that is a very quick run through of the guidance on climate proofing that we published. It's about 100 pages and it's available for free from the official journal of the EU, and you find a link on the, I think, slide number 2. Thank you.
Thank you very much, Mr. Kundrup, for this presentation. Obviously, when we look at your slides, the topic is very complex and incorporates a lot of different criteria, and it certainly requires some time for analyzing and going to the different details with the approach regarding mitigation, climate neutrality, and adaptation and climate resilience. I think that we have a question again from Stefan, please. Your mic is off, Stefan.
Sorry.
Okay, we hear you.
Thank you, Mr. Kondrup, for a very interesting presentation. I have a few questions. First one is technical. On page 3, you mentioned EIB, carbon footprint, or carbon calculation. So I guess EIB is European Investment Bank, but why do you mention? I mean, do they have a tool that should be used in this analysis? So I don't understand why they are mentioned, or if I'm right, that is the right meaning of EIB. So I don't know. Yeah.
If I can answer that one, the EIB is indeed the European Investment Bank. And for the mitigation pillar of climate proofing, we use the carbon footprint methodology developed and implemented by the European Investment Bank. And that's what we have tried also in practice for the major projects.
Okay.
And it's possible to use other methodologies, but the EIB methodology is documented and ready to use for many types of infrastructure and acceptable. Okay. So it's supposed to be ready to use.
So it will be the reference in the European Union.
So it is the reference, but if you have something better at hand, you can also use that.
Okay, and this one is available, I guess, and we can.
There are links in the guidance to the carbon footprint methodology.
Okay.
The guidance includes also the cost of carbon that you need to include in the cost-benefit analysis.
Okay. Okay.
And
okay.
And I noted that the guidance is complex or long, 100 pages. It responds to the legal requirements, and they are short. Legal text is usually very brief, but then it's built on the experience and what we have tried out with major projects in the period 2014 to 2020. So it can actually be done in practice, which is really reassuring.
Okay, okay, thank you. I have another question, Christophe, but if you see somebody else.
Well, Stefan, so far, apparently, well, there's no other question, so please feel free to ask another one.
Yes, so you mentioned two steps, the screening and then the detailed analysis. So this detailed analysis in particular, so this is done in member states by the countries, by the project owners, I suppose, and then who is reviewing, who is approving the result of this analysis? Is that you? Is that the country managed on its own? How does it work?
In the previous 7-year budget period, 2014 to 2020, with major projects, we had an entire system that going through the projects, the appraisal of the projects, the development of projects, and each major project was subject to approval by the European Commission. Now, in the current period, 21 to 27, that is no longer the case. We have more funds and we have more types of infrastructure that can be funded. And there, the approval is done as part of the financing decision, which in the case of cohesion policy is done in the member state, which in the case of Connecting Europe Facility is done by the Commission. So there are different ways that the approval can take place of the project or of the funding. And that's also why we have asked for the summary of the climate proofing process, this 10 to 20 page summary. So that is to support the investment decision. And then if there are gaps in the analysis, to go deeper when that is needed.
Okay, yeah, okay, clear, thank you.
So the 2 steps is it's a legal requirement for InvestEU. It's part of the legislation on InvestEU, but it's also integrated in the guidance because it makes really good sense not to do a detailed analysis for projects where it's not necessary.
Okay.
Okay, thank you. We have another question. What is EU methodology in respect to life impact, in respect to cost and carbon emission and climate impact of any infrastructure system, and how are those considered?
Could you repeat the question, please?
Yeah. What is, or maybe we could ask the person who have sent that question to ask the question orally. Maybe that would make the dialogue easier. It comes from Herman Volk. Maybe can you please raise your question?
Yeah, good evening, everybody. Thank you very much. The question was in respect to if we discuss any infrastructure system, and I'm referring to the presentation of Jim Mack, where he compared concrete and asphalt, and he was, let's say, concluding that concrete pavements over the lifespan of a system are more, let's say, economic and as well more climate, how to say, friendly compared to asphalt. And how is that considered in your view and evaluation and requirements to any future infrastructure?
I can answer how we're starting to look at it in the U.S. methodology, if that's what you're looking at. And so, let me go there, and then I'll hand it over to Klaus. Essentially, what we're doing in the U.S. is we want to add this to a part of our life cycle cost analysis. And so we're going to add a risk analysis where we look at what's the risk of an event happening, and then so what's the probability of that event happening? And then if it does happen, what is the financial cost associated with that happening? And from that probability of the risk happening and what is the cost of that risk happening, and we can look at high events, low events, different types of events, we can come up with a cost associated with the mitigation techniques of the different things and what those are. So we can look at flooding. And so for example, when we're looking at flooding, we actually can model the performance of the different pavements based on different moisture conditions. We can look at the damage in the future, and we can model that and say, hey, there's very little damage, so there's not a whole bunch of extra cost, or there's a lot of damage, and so there's going to be a whole bunch of extra costs, and we put that into our analysis procedure in the evaluation process. So it's a risk-based analysis, and so that's how we've been. Our U.S. Congress has told us that we need to use risk-based analysis in our evaluations of our pavement systems, and that's the process we're working at implementing.
And the question was more or less addressed to European Commission, and the question is: do we have this kind of same, how to say, precast methods to look into different infrastructure systems? To evaluate, okay, it's cheaper to install, it's less carbon to install, but on the long term, the other system would be more, let's say, competitive and even more friendly to cost and as well to carbon emission or climate.
If I can put it differently, the guidance is asking that the project developer will have the usual technical team, engineers, economists, to prepare the project, and added to that team should be the climate expertise. So that the typical team that the project developer will use, the engineers, etc., also include climate expertise. The guidance is covering all kinds of infrastructure that you could fund with EU funding in this period, 21 to 27, but it's not specific, it's not comparing asphalt with concrete pavements.
Okay.
That's up to the project developer, who might be the National Administration of Roads.
Okay.
They would develop it further, just like James is explaining in the US. Then I think we have the same approach for the climate resilience, and that is a risk-based approach.
Yeah, and that's what I say. We're applying the same process to both carbon and cost and doing that. And again, it's an infrastructure thing. We've pulled this process. This is how they evaluate buildings here in the U.S. and the whole resiliency around buildings is much more advanced in the U.S. than the infrastructure, and we're trying to apply those same type of concepts to the pavements.
Okay. Stefan, I think that you have a last question. We need to go to the end session of this event, so please be quick if you can.
I have a last question that linked to the one that was just asked. So I understand. I mean, the type of pavement is not your concern, or it's more up to the development teams to look into these topics. Clear. But is there a way, or do you think you will put emphasis, on checking that actually the available solutions have been compared and evaluated in order to pick the best one? Because yeah, I mean, we are confronted to the issue in some countries that actually they don't look at the alternative that exists. And in order to get the best outcome for European Union and for sustainability in general, it would make sense that the potential alternatives be compared so that the best solution would be used eventually, not just to use a good solution, but to look for the best and compare the alternative. And yeah, so, and this is not a technical, analysis that is needed. It's just to see, okay, have they compared alternative or they just propose only one? So, and it would be very, very valuable to us that if this type of checks were done, when you approve this detailed analysis.
But that detailed analysis, for example, if the EU is funding road projects in a member state, we would expect the National Roads Administration to do that type of analysis to find the optimal solutions for their infrastructure. And it's not at that level of detail that the guidance is going into. But the guidance is obliging the assessment of the greenhouse gas emissions and to reduce greenhouse gas emissions and to look at climate resilience, which is a step forward in the European context for some of the member states.
Okay.
Okay. Thank you. Thank you very much, Mr. Kundrup. Now we go to the part of debate, and I would like to ask a very first question to all our speakers. What are, according to you, the main challenges to be addressed and or the main obstacles that need to be overcome when we talk about resilience, climate resilience, and more particularly of long-term transport investment? And in our case, we obviously focus on the road infrastructure. So who wants to start?
I can start with that. I think that here in the U.S., our biggest obstacle is addressing what Stefan just talked about, having people look at alternative solutions and ways to do things. A lot of the practice is more justification of what I've been doing and maybe looking at things and tweaking to get a little bit better performance. It's not a wholesale, let's look at our whole process and change fundamentally how we approach infrastructure. We still see it as a pavements as a piecemeal type thing. And so I think our biggest roadblock is getting people to look at different alternatives and comparing those and putting there. I think we have the technical aspects of it. I think the US leads in some ways because they have some good technical aspects of how to evaluate pavements and do stuff. I think the Europeans lead in a lot of ways with the standards and the technical guidance and kind of laying all that out. We need a merger of those two systems so that we can do the evaluation in a much more comprehensive way and have those done. I think, like I say, I think the Europeans lay out how it needs to be done. We just need to actually force those types of evaluations to be done.
Okay, quite interesting, this approach of merging two different approach or behaviors. I think it's really interesting to see that a combination of both could really bring some benefits. Another reaction to that question from Mr. Kondrup or Luc?
Yeah, if I can make one, I think time is important, but it's about the time horizon, because I imagine that for the payment, it lasts 10, 15 years, and then you have to replace it. So you have one set of decisions for the payment and what you would put as an extra payment after 10, 15 years. But for infrastructure, we also have longer lasting decisions to make, like the height of a bridge. And there we have to deal with the uncertainty, because it's easier for us to estimate the extremes we will have the next 10, 15 years than what we will have in 30 to 50 years. So the time horizon for the different aspects of the infrastructure, I think, is important.
Yeah, and I think this is where it is. We are actually looking at 75 years for the pavements, even in the U.S. So that we're looking at those long time frames also, and that's an important aspect. So we recognize, like you said, the bridges need to be part of that discussions, but the pavements, and then how we do that from a probabilistic or a uncertainty principles, take those into account. Those are where we're working at, and that's, I think, some of the portions where I think the U.S. is maybe a little bit higher, but I think the standards were into the evaluation process is where Europe's better. So,
yeah, I think it's quite interesting to have this criteria of the life cycle. We are talking about infrastructure. The roads themselves have different components that also have different life cycles and momentums, and also the let's say another element, which is the road users. The different types of road users also bring different other criteria as well of life cycle duration, which need to be taken into consideration. So yeah, Luc, do you have any remark on that question?
Well, yes, it's precisely the misunderstanding that we are advocating indeed for also a long-term vision and long service lives for pavement, which is possible with concrete. And then the challenge is indeed to convince decision makers of taking the good decision of a future-proof solution, requiring a higher initial investment. And so it is investing for the future, in terms of cost, in terms of resilience, and that will remain a challenge for concrete pavements.
Okay. And as we talk, I will just get to the last question, but as we talk about investment and money, a question related to the investment. Have there been any investigation in terms of return on the investment for making transport infrastructure, and more particularly making pavement more resilient? Do we have any data? I know this is always a very difficult discussion. Is there any way to quantify or to get more accurate details about the return on investment?
Anybody want to go first, or I can go?
Well, I already said something at the end of my presentation about the public-private partnerships. And in that case, it is the whole group, the consortium, which designs and operates for a projected service life. And so they are in charge, they're responsible, and that will make it easier for them to make the right choices on the long term.
Yeah. One of the things we've seen here in the U.S. is a group called AASHTO. It's the state DOTs, it's their associations. The AASHTO, FHWA, and a few other groups have looked at how to build in resiliency. And so they talk about prevention, protection, mitigating, response, and then recovery. And what they have found out is, and they haven't looked specifically at pavement, but they've looked at all other types of infrastructure type things. And they found that when you do things that do prevention or protection or mitigating, the return on investment is somewhere between 2 to 9 times every dollar you spend. So it's a 2 to 1 to a 9 to 1, depending on what you're looking at. Once you get into responding and recovering, it's a major negative and ROI. So at that point, that's why AASHTO and the FHWA is really pushing, hey, focus on the mitigation and the protection of the system and trying to build out of it before it actually happens.
Okay, that's quite an interesting information, really, and it goes into the definitely in the sense of the long-term investment in transport infrastructure. Thank you very much. I think that we are now progressively going to the end of this quite interesting event. And before finishing this session, I would like to give again the floor to Stéphane for the final conclusions and the closing remarks.
Thank you, Christophe. I try to be short. So I think it's clear after our discussion today that it's worth investing today, not tomorrow, in road resilience. The social benefits will be saving people's lives and protecting economies. It's also clear, I think, that concrete can be part of the solution, a big part of the solution, as concrete roads show better resilience. In the case of flooding, because of its stiffness, like Mr. Jim Mack made a very clear case. It's also clear that the European Commission's technical guidance on the climate proofing infrastructure will be a powerful instrument to help the EU member states to mitigate and adapt infrastructure to climate change. And our dear wish is that it finally leads member states project owners to compare alternative techniques and type of pavements in an open manner to select the best options to achieve the best possible outcome for the society and the environment. This said, yeah, I would finally would like to say that the European Parliament, the European Commission, as well as other administration will always find a friend in EUPAVE. We are and will always be willing to collaborate, discuss, and help implementing all the policy which protect environments and bring more resilience and innovative infrastructure. So that, yeah, it helps us to all have a brighter and more sustainable future. So with this, I would like to thank everyone for coming and participating in this important debate. Thank you a lot, Mr. Klaus Kondrup, for giving your expertise from the Commission in this debate. Thank you, Mr. Jim Mack, for sharing with us the approach in the US on this topic of resilience. And thank you, Mr. Nicodem, for your presence and contribution to moderate the debate. So thanks a lot. And I hope to see you soon again. Or yeah.
Thank you very much, Stéphane. I would like to give great thanks to our host today, Ms. Isabel García Muñoz, to EUPAVE, the organizer, to all the speakers and to all the participants. And before leaving you, I would leave maybe Elise give you some practical information regarding the availability of the presentations and the recording of the event. Thank you again very much for your participation and have a nice evening.
And on my behalf, sorry, I had forgotten to thank Mrs. Isabel Garcia and her team. Sorry about that, and thanks a lot, of course, for hosting the event.
Thank you, Christophe. Yes, so the presentation and the recording will be made available on the website. I will also send it by email to those who registered. So if you are participating but you didn't register before, you can email me. My email address is on the screen. Just give me your contact details and I will send you the information.